Good morning, everybody. Welcome to another exciting morning of Chem 1211 with me, your host, Dr. White. Hope you all had a nice weekend. I was so busy grading labs and other things. All right, everybody, make sure you're getting your labs in because after this Thursday and Friday, no leeway. Got a whole week plus about 2 days more to get them in, so please get them in. All right, where should we begin? Where we left off. We talked about a mole, and 1 mole equals Avogadro's number of either atoms for an element or molecules for a compound. Everybody see that on the screen? Thumbs up, people. Thank you. And let's do a practice problem right off the bat. And I'll do this one, then I'm going to have you try one because you know I'm going to share the fun. Let me just, there we go. So the question is, how many moles are 2.11 times 10 to the 33 molecules of water? So what are we trying to find? Moles of water. And I could have put up here moles water. And what are you given? This. How many molecules of water do you have? And guess what time it is? Nope, it's not howdy doody time. I just did a generation gap on you. It's time to use your good buddy, your good friend, unit analysis. And how do you use unit analysis? This is the only number we have to start with. So I'm going to start with that. And if there was some magic ratio that I could multiply this number by, what units do I want my answer in? Well, I took the time to figure that out. It's right here, moles water. And now how do you use unit analysis? Whatever you're trying to get to goes on top of the ratio. Whatever units you're trying to get rid of go underneath on the bottom, otherwise known as the denominator. Ooh, I still remember from first grade when our teacher taught us, remember Notre Dame, but I went to Michigan State and we don't like that college. But anyways, moles go on top and molecules of water go underneath. And where do we get the numbers that go in there? You know, and it will be in one mole of a compound equals Avogadro's number, 6.02 times 10 to the 23rd molecules of a compound. And if two things equal each other, A equals B, there's two ratios you can have, A over B, and this is not equal, and B over A. So if I have 1 mole here, from here, what do I put here? 6.02 times 10 to the 23rd. Now, before I pick up my calculator, and in your case, you pick up your calculator, what am I going to do? Use unit analysis again. Notice molecules are divided by molecules, and anything divided by itself equals number one, which means it's canceled out. And this cancels out. What am I left with? The units I want. And now I feel confident that if I go to my calculator, I'll get the right answer. But before I move on, let's talk about taking tests, Dr. White's test, which in a couple of weeks, test number 2 will be coming up. And what's important when you have a problem like this, if you just put down the answer and it's right, you'll get your 5 points. If you just put down the answer and it's wrong, including significant figures, you'll get 0 points. But if you show your work, you'll get most of the credit if you made a math error or rounding off error or significant figure. So it pays to show your work. And I did. And now I'm going to go to my calculator. Let's make this a little larger calculator. And if we come over here, and I have 2.11 times 10 to the 33rd divided 6.02 times 10 to the 23. I hit enter, and oh my goodness, look at the big number my calculator threw at me. And now you got to round it off. Remember, Avogadro's number is 3 significant figures. The number 1, the mole, and I'll show you in a second, was exact number, doesn't play a role in there. And 211 is 3. So how do you round this off to 3 significant figures? Keep the 3, keep the 5, keep the 0. Those are my 3. Use 4 to round off. That's 4 or less. So I drop this. So that would be 3.50 times 10 to the 9th, which is your answer. And the answer would be 3.50. Hold on one second. One of these days I'll figure out how to do macros on my pen for color change, but not today. And that's how you do it. You find out what are you trying to find, calculate, determine, and the units, what are you given? You put this here, you put the units you're trying to get over here, you use a ratio. How do you get the ratio? Using your good buddy, your good friend, unit analysis, whatever goes on, you're trying to get to goes on top, whatever you're trying to get rid of goes underneath. Where do you get these two numbers? From this knowledge that 1 mole of a compound equals Avogadro's number of molecules of a compound. And why don't you try one? And here's one for you to try. How many molecules are 18.76 moles of hydrogen gas H2? And remember, on test number 2, important information, you will be given 1 mole of an element equals Avogadro's number of atoms of the element. 1 mole of a compound equals Avogadro's number of molecules of that compound. Good question from one of your colleagues. So Avogadro's number is 6.02 times 10 to the 23rd, and 6.02 is 3 significant figures. Avogadro's number is a calculator, and this is rounded off. If you go online, you can find it easily. I think it's 7 or 8 significant figures. I think I one time saw it somewhere around 18 significant figures. All right, someone just asked, and I'll do it for a simple number. And this is the beauty of scientific notation. And that is, how would you write, and I'll just make up any number, 3 as 3 significant figures, because that's only 1. Well, if say 3 times 10 to the 5th, well, I can do this. By adding a decimal point and 2 more zeros, I now have 3 significant figures. And you can do that as many as you need. If you only needed 2, you'd put 3.0. And that's the beauty of a decimal point and zeros. All right, everybody give me a thumbs up when you're done. See, a number of people are thumbing up at me. Is that a right way to say that? That doesn't sound good. Giving me a thumbs up, that sounds more professional. All right, let's do this. How do we do this? First of all, what are we trying to find? How many molecules? H2, because this is what we're asked here. And I see a question. Hold on, hang in there. Oh, somebody's already got the answer. I'll see if they did it right. All right, let's continue on. And here you have 18.76 moles of H2. And how do you begin? This is the only number we have. So I'm going to start with that because that's all I have. If I had a ratio, I could multiply this number to what units do I want my answer in? Well, we figured that out. Molecules of hydrogen gas. And I see a question, or does somebody also pop up with the answer? A correction. Anyways, now it's time to use your good buddy, your good friend, unit analysis. Whatever you're trying to get to goes on top the units. Whatever we're trying to get rid of go underneath. And where do we get these two numbers? From this relationship. And that is 1 mole of a compound equals Avogadro's number. So first I'm going to write this in here, and this should be moles of hydrogen. And 1 mole, by the way, this is an exact number because part of the definition, equals Avogadro's number of molecules. Now, before I begin, I'm going to check do my units cancel out. Let's see another question. Someone just asked a pertinent question. When you're using Avogadro's number to three significant figures, if the number you're given is three or more significant figures, then your answer will always be three significant figures. In this problem I'm doing, if I just put 18, then your answer would have been two significant figures. All right, let's check and see if our units cancel out. Remember, anything divided by itself equals number one. Moles divided by moles of hydrogen are the same. They cancel out, and I'm left with the units I want. So now I'm ready to go to my calculator, and let's go. And I hit the button, and I get this number. And this should be three significant figures. So I'll let you round it off for three significant figures. I'll give you 3 seconds for three significant figures. I threw in another 3 seconds, and you keep the one, keep the one, keep the two. That's your three significant figures. Use the 9 to round off. That's 4 or higher. I'll drop all this and increase that. So the answer is 1.13 times 10 to the 25th. And that's how you do it. And this is a quick practice of what we did last week. And let's move on to some new stuff. And I have a request, and the answer is, of course. You want to go molecules to moles. Okay. What was your request? Hang in there. And I didn't do what I was asked. So let me just redo this. Sometimes I get on a train of thought and it gets derailed. I think that's what was asked. Why don't you try that one? Let me see if I. All right. I finally got it right. So here's one more for you to do on this sunny day without snow. Yay. It's been a whole week since I had to play with my driveway. Yay. Double yay. In fact, I was looking at a seed catalog to see what do I want to plant this summer, so I better order soon. A couple of years ago, I had an organic class I taught, a student who worked in a real big company that sold, you see them around here, that sells flowers and all sorts of plants. And I asked her, what's the best place to get seeds from? And there's a place called Johnny's Seeds or something, and I bought from them now 2 years in a row. This will be the third. And it's time to order some basil seeds, and I don't know what else I'll plant. Maybe oregano and dill and mint. I do the herbs. Oh, it makes me feel so good to see everybody working on their moles and molecules problems. Thank you. I'm thinking this Wednesday, we're going to have everybody turn on your camera day. That would be interesting. I'll have to ask how many of you would be in favor of that. Speaking about this week, I know some of the problems in chapter 10 problem set are repeated from 9. There are a few new ones. So this Thursday and Friday for lab, let's do those. Chapter 10. And then next week we'll do chapter 6 and probably 8. Maybe do 2 in one lab. You're up to it. All right, anybody need more time? Going once? Going twice? Well, nobody's yelling at me, so let's do it. All right, how do we proceed? Find out what are you being asked to find. How many moles? KOH, potassium hydroxide. What are you given? 3.5 times 10 to the 43rd molecules, if I can spell it right, of KOH. So now you use your good buddy, your good friend, unit analysis. And I see a question or somebody's already got it done. Somebody's already got it done. I'll get back to you in a second. And now we have 3.5 times 10 to the 43rd molecules of KOH. And what do we want to get to? Well, we took the time to figure out the answer unit-wise is moles of potassium hydroxide, KOH. And now it's time to really use your good buddy, your good friend, your analysis, whatever you're trying to get to. The units go on top of the ratio. Whatever you're trying to get rid of, go underneath. And this is moles. Moles of KOH underneath. Molecules, KOH. Where do I get this number? Important information you will be given. I used to make students memorize this, but I don't. 1 mole of a compound equals Avogadro's number of that compound. And you should know by now Avogadro's number is 6.02 times 10 to the 23rd. So 1 mole of a compound equals Avogadro's number. So I can do this ratio. And now before I pick up my calculator, do my units cancel? Molecules of KOH divided by molecules KOH cancel out because anything divided by itself equals 1. And now I'm confident that I can go ahead to my calculator and get the right answer. Remember, show your work like I did, and if you make a mistake, you won't get totally lose all points. So I have 3.5 times 10 to the 43rd. Notice that's two. Yes, two significant figures. And I'm going to divide it by Avogadro's number, 6.02 times 10 to the 23rd. And here's the number I get. However, if you put this down, I'll take off a point because on test 2, like test 1, it will say, please use proper significant figures for all calculated answers. And now we have to round that off to two significant figures. How do you do that? Keep the 5, keep the 8, use those are my two significant figures, and the 1 to round off, that's 4 or less. So I'm going to drop it and everything afterward. So the correct answer is 5.8 times 10 to the 19th. Moles of KOH. Oh, that's a lot of moles. Let me rewrite it here so you can see it better. And that's how you do it. All right, time to move on. Now, there's something called molar mass. And molar mass for an element, otherwise known as elemental or element molar mass, is the quantity in grams of an element that's equal to the atomic mass of an element. And I'll never ask this on a test, but you will need to know it, and I'll show you a way to remember it and see it. You won't have to memorize it, though. I'll give it to you important information. We also have molecular mass, and that's the quantity in grams of the formula weight, also known, Dr. White will say molecular weight, of a molecule, which equals the formula mass of a molecule. That doesn't sound too straightforward, but let's look at it a different way. And this and the answer is yes, this is still in chapter 6. If you don't believe me, oh, look at the top. It still says chapter 6. And now what you should also know how to use. And that is 1 mole of an element equals the atomic mass in grams of the element. And you know, when I do all this stuff, when I was in college, I knew I better know this stuff for the test. So for elements, 1 mole of an element equals the atomic mass in grams of the element. And for compounds, 1 mole of a compound equals the formula mass in grams. And I'm going to be using molecular weight, which is just another way of saying formula mass in grams. So 1 mole of an element equals the atomic mass in grams. 1 mole of a compound equals its molecular weight in grams. So what does this mean? Well, first of all, it means I've got to open up a periodic table. All right, everybody see the periodic table? Thank you. All right, so what that means is, how do I get a mole of sodium? If I said, go to the lab and bring back a mole of sodium, well, you're not going to be able to count 6.02 times 10 to the 23rd atoms. Nobody can. But you can go to a balance and weigh out, and that would be the three significant figures. Remember, on test one, it'll be true on test two, use all atomic weights, the three significant figures, round them off, and that'd be 23.0. So if I wanted a mole of sodium, I would just have to weigh out 23.0 grams. For magnesium, that'd be 24.3 grams. For what's another one I have? Iron. A mole of iron would be 55.8 grams. And that's one mole of an element equals its atomic weight. Now, determine the mass in grams for one mole. Well, for silver, let's go to the periodic table. And maybe I didn't switch over. Bernice, I think through chapter 8, 5, 6, 7, and 10, and 8. I might have mentioned this. Historically, test number 2 has the lowest average of all my tests. However, last semester and a number of summers ago, a class proved me wrong on that. So if you're keeping up with the problem sets, you'll go good on test number 2. And that's why I have the problem sets. But I've been parsing Chem 1211 this way for many years. And if you keep up with the problem sets, students do good. So take a deep breath. Don't let all those chapter numbers spook you. Oh, I haven't used that word in a long time. Relax, you'll do it, and I'm here. Speaking about, time for a quick commercial from Dr. White. Don't forget tonight from 6 to 7:15, I have my office hour, also have it Wednesday. So come on by. So if I want to find how many mole, what is one mole of silver weigh, I find silver Ag, and the three significant figures, the atomic weight is 108. So if I wanted a mole of silver, bring me 108 grams of silver. If I wanted a mole of gold, that would be 197 to three significant figures. So bring me a mole of gold. Yeah, I wouldn't mind that. And that's how you do elements. Now, how do you do a mole of water? If I asked you to go to the lab or go to your kitchen, bring me, if you had a balance in your kitchen, bring me a mole of water, what do you do? Well, you remember that one mole of a compound equals the molecular weight of a compound, and the molecular weight of a compound, this will be given to you. And this is also stuff we've talked about that you should know. It's very important. And I don't ask you to memorize this anymore, but you should know how to use it. The molecular weight of a compound equals the sum of the atomic weights of a compound. So if we're trying to get a mole of water, we need to know what's the molecular weight of water. How do you do that? Well, water, H2O, and that's 2 hydrogens and 1 oxygen. I put the dot there so you know it's not the number 10. And 2 times what's the atomic weight of hydrogen to 3 significant figures? 1.01. 1 times an oxygen to 3 significant, 16.0. Add these together. Remember, you get the same number of significant figures to the right of the decimal is the number that has the fewest. This is 1, this is 2, 1 is the lowest. So the correct answer, 1 mole of water is 18.0 grams. So if I need a mole of water, all you have to do is weigh out 18.0 grams. Now, I'm going to let you try one. What would be the weight of 1 mole of ammonia? And let me just tell you that this is 14.0. The atomic weight for nitrogen, hydrogen is still 1.01. Have fun. Your turn. What would 1 mole of ammonia weigh? While you're doing that, I should make a quick public service announcement. Over the weekend, one of your colleagues told me how well my reducing test anxiety method worked for your colleague. And if you don't know how to use it or you weren't there when I taught it, come to my office hour and I'll be more than happy to do it again. But I was told it works quite well. Person was taking a nursing entrance exam test. All right, anybody need more time? Time's up. Let's do this. What is the weight of 1 mole of ammonia? 1 mole of a compound equals, and I'm going to use the abbreviation MW, molecular weight in grams of the compound. So for ammonia, we have 1 nitrogen and 3 hydrogen. And the atomic weight of nitrogen to 3 significant figures, that's the number underneath the element's symbol, chemical symbol, is 14.0. For hydrogen, it's 1.01. Do the math, 14.0, this 1 times that, 3 times that is 3.03. Add them together, you got 17.03. But remember, you get the same number of significant figures to the right of the decimal as the number that you're adding that has the fewest significant figures. This is 1, this is 2. I keep this, use this to round off. Is 4 or less, drop it. And the right answer here is 17.0 grams. And that's how you get 1 mole of ammonia. And we're not going to do sodium hydroxide, the same thing. Let's move on. Now, let's do some calculations converting from moles of an element to grams, moles of a compound to grams, and vice versa, grams of an element to moles of that element, and grams of a compound to moles of that compound. And I could have written here gold instead of AU, but I didn't because organic chemists are lazy. So the question is, how many moles of gold are 568.1 grams of gold? So what are we trying to find? Moles of gold. What are we given? This number. And now once we've done this, you never have to look at the word problem again. Yes, these are word problems. Relax, take a deep breath. And so the only number I have to work with is this. Don't forget the units. And if there was some conversion, I could use what would be my answer unit-wise. And the answer is moles of gold. And now, once again, it's time to use your good buddy, your good friend, unit analysis. I love my siren. And how do you use it? Whatever you're trying to get to goes on top of the ratio. Whatever you're trying to get rid of goes underneath. And here I have mole of gold. Here I have grams of gold. Where do we get those numbers? 1 mole of an element equals its atomic weight. And here's the abbreviation in grams. And where do you get that? From the periodic table. And if we look at gold, the 3 significant figures, it's 197. So 1 mole of an element equals 197 grams of an element. And before I pick up my calculator, I'm going to look and see, does the units cancel out? And if we notice right here, we have grams of silver divided by grams of silver. Anything divided by itself equals 1. This cancels out. I'm left with moles of, not silver, gold. And that's what I want. So now I'll go to my calculator. And you could do this in scientific notation or not. Either way is correct on the test. And I have 568.1 divided by 197. Notice the top is 4, the bottom is 3. My answer should be 3. And therefore, rounding that off to 3 significant figures, keep the 2, keep the 8, keep the 8. Use the 3 to round off, that's 4 or less. Drop it, so it'd be 2.88 moles of gold. And that's how you do it. One thing I should point out, if you have your calculator in scientific notation, is something that sometimes gets students confused. Let's do the same thing as if we're in scientific notation. And notice it has 2.88 what extra times 10 to the 0. And you might see this. What do I do? And here's what that means. 10 to the 0 equals the number 1. So if I have 2.88 times 10 to the 0, 1, if you put that down in the test, I'd mark it correct, I'd smile. But what this really is, 2.88 times 1, because this is 1, because 10 to the 0 equals 1, equals 2.88. But if you do it, you don't want to take your calculator out of scientific notation. If you wrote that answer or 2.88, both would be correct in my book. Oh. And did I tell you I'm this close to the person who grades the test? Me. And somebody asked, do you want me to go over that problem from the beginning again or just show it to you? Is this the one you wanted me to show again? Oh, by the way, Dr. White got caught up with all his videos. Oh, that reminds me. The ammonia one. Oh, I know. Thank you, Kelly. I'm looking for on my whiteboard. It wasn't on my whiteboard. It's right here. There's the ammonia one. Remember, 1 mole of a compound equals the molecular weight. The molecular weight is the sum of all atomic weights. 1 nitrogen, 3 hydrogen. Atomic weight of nitrogen, 14.0. Hydrogen, 101 to 3 significant. Multiply, add, round off properly. And hopefully that is that. I'll let you catch up and write it down if you need to. All right. By the way, if you want a good laugh, I think I did a good job, but I'll let you be the judge of that. Last Monday, for whatever reason, the video got messed up and I couldn't use it. And that happens once in a blue moon. Ooh, this did a generation gap on you. Anybody ever hear the song Blue Moon? That was a favorite of mine when I was in 8th grade. Wow. But anyways, so Saturday, I faked the whole lecture. I pretended everybody was out there, and I did the first part. If you remember, I went through test number 1, so I didn't repeat that because I always cut that out of the video. And the second part, I covered what we had covered on Monday, and you'd go take a look and see if you like how I did it. And how can you tell no one was there? Because you don't see any pictures on the screen except me. Dr. White's pretty inventive when he has to be and creative, which is a good thing. By the way, who's ever there, say hello. Dr. White says hello. And I won't even charge you extra. All right, looks like it's time for a break. Time for Dr. White to take a stretch. I'll see you in 5 minutes. That's 5. And I'll see you in 5 minutes. And come back at 10:55.
It took 43 minutes. Because that's how much you make. Well, how much am I supposed to make? How much am I supposed to estimate? Am I supposed to grab a big jar, dump like half of the peanut butter, and then just grab?
Someone have a question or just your mic's on?
It's good. It's like not really healthy, but kind of healthy.
It seems like their mic is on.
Yeah, it's no, this. All right. In search of a. I think we got everybody's mic off. Let me check. There we go. Once in a while, somebody turns on their mic. Oh my God, I'm running late. Oh no, I'm late. I'm late for a very important date. Where's that come from? Alice in Wonderland. Wow. All right, quick announcement from Dr. White. For those of you pet lovers, stick around after class for a couple minutes. Dr. White has a show and tell. So if you're a pet lover, stick around after class, and because I'm going to take it out of the video. So let's get back to work. All right, whoever has their mic on, turn it off. Thank you. All right. Now, remember, 1 mole of a compound of an element equals its atomic weight in grams. So let me have you try one. So how many grams of sodium is 5.671 moles of sodium? And this is a question mark, not a number 2. And oh, it's an ugly looking question mark. Hold on. Now I feel better. And to help you out, you might need this. The atomic weight of sodium to 3 significant figures is 23.0. So it's your time to get going. And let me get something. Don't forget to use your good buddy, your good friend, unit analysis. Oh, I see a Z on the screen. was just wondering, those of you who have your webcam off, if you're in a classroom, do you wear a brown paper bag? Oh, that was bad humor even for me. The anonymous students. Just think you have a whole week of me on bad jokes to look forward to. Hopefully I'll up my game and do some good jokes too. All right, anybody need more time? All right, let's do this. So the question is, how many grams sodium is 5.671 moles of sodium? So what are we trying to find? Grams of sodium. What are we given? 5.671 moles of sodium. And what do we know? 1 mole of an element equals its atomic weight. So the only thing I have to start with is this. 5.671 moles of sodium. And if I had a ratio that I could convert the moles of sodium, what units do I want my answer in? Well, we took the time to figure that out, and that's grams of sodium. And what time is it? It's, hold on one second.
Analysis time?
Nope, I'm still recording. For a second, I thought I stopped the recording. And what time is it? It's time for unit analysis. You're a good buddy. You're a good friend. I've got a big collection of whistles. And therefore, I'm going to use my good buddy. Hold on, I see a question. That's right, new sound. And I'm going to use my good buddy, my good friend, unit analysis, which teaches me whatever I'm trying to get to goes on top of the ratio. Whatever I'm trying to get rid of goes underneath. And this is moles of sodium. This is grams of sodium. I see another question. Yep, I do keep you on your toes. And this is not even ballerina class. Oh, that was awful. All right, let's get back to chemistry. Where do I get these numbers? 1 mole of a compound, 1 mole of an element equals its atomic weight, which I gave you right here, which you get from the periodic table. And now, before I pick up my calculator, I'll see if I get the right units. Remember, anything divided by itself equals the number 1 and cancels out. Moles of sodium divided by moles of sodium. What am I left with? Just what I want. Grams of sodium, that's all that's left. So now I'm going to go to my calculator. And this is a number my calculator gives me. And one of the numbers was 4 significant, the other was 3. and you should round this off to 3 significant. Now, this is an interesting one, and I'll show you something why scientific notation helps. And I keep the 1, keep the 3, keep the 0, use the 4 to round off. It's 4 less, drop it, but I get 130. That's only 2 significant figures. So what do? You switch back to scientific notation. Switch back to the right slide first. Wow. And now, how do you write the number 130 in 3 significant figures? Well, use scientific notation. And if you kept your calculator in, how do you write this? 1, 2, and that's how you do that. So that would be 3 significant figures, and that's how you do that. All right, let's continue on. And notice there's a lot more points, and I'll show you why. And the question is, how many moles of water is 26.7 grams of water? So what are we trying to find? Moles of water. What are we given? 26.7 grams of water. This is the only thing we have to start with. 26.7 grams of water. If we had a ratio, we could multiply this by what units do we want our answer in. And the answer is moles of water. And it's time to use your good buddy, your good friend, unit analysis. And better hurry up before the train leaves the station. Oh, that was bad. And using your good buddy, your good friend, unit analysis, whatever we're trying to get to goes on top of the ratio. Whatever we're trying to get rid of goes underneath. And I see somebody has a statement or a question, so I'm going to go check. All right. And now, change color pens. Whatever units we're trying to get rid of, in this case, grams of water, go underneath. Whatever we're trying to get to, moles of water, go on top. And where do I get that number? And you get that number. This will be given to you important information. Test number 2, mole of a compound equals the molecular weight. That's what MW in grams of the compound. Oh no, he didn't give us the molecular weight of water. Well, you're going to have to calculate that. And the molecular weight in grams of a compound equals the sum of the atomic weights. And I'll abbreviate it, of the compound. And therefore, we need to find out the molecular weight of water. How do we do that? Well, water has 2 hydrogen, 1 oxygen, and now the atomic weight to 3 significant figures of hydrogen is 101. For oxygen is 16.0. Let's find out if I'm lying to you or not. I might. No. If you notice here, hydrogen 1.008 to 3 significant figures, that's 1.01. Oxygen right over here, 15.999 to 3 significant figures, that's 16.0. So, and that's how you use your periodic table to find this. I will now multiply this, add it up, and you get the same number of significant figures to the right of the decimal as the number that has the fewest. This has 2, this has 1, which is the lower number. Hopefully I'll pick 1. Therefore, round this off, it's 18.0. And 1 mole of a compound equals its molecular weight. And now I'll take 26.7. But wait, no, stop. Put on the brakes. Check to make sure your units cancel out. How do you do that? Notice grams divided by grams of water. Anything divided by itself equals number 1, meaning it cancels out. This cancels out. I'm left with moles of water, which is what I'm trying to get. So now I can go to my calculator and this is the number I got. Let me make sure I calculated, I copied it correctly. Yep. And this should be 3 significant figures. I'll let you round that off to 3 significant figures. I'll give you 5 whole seconds to do that. Go. I'll sneak in a water break too. Time's up. 1.48. That'd be 1 point. Keep the 1, keep the 4, keep the 8. 3 is less than 4. Drop all those. So the answer would be over here, 1.48 moles of water. And either somebody wrote me the answer and they did it themselves, or that would be MW molecular weight. Which part? Let me go through it again. 1 mole of a compound equals the molecular weight in grams of the compound. Okay. Oh, look out, Dr.
Wait, I have a question.
Go for it.
Below that, where it says same of the blank weight, there you go. Wait, you just had it.
Hold on, ask your question again.
Excuse me. It says molecular, I can't say.
This
Yes,
one
right there.
All right.
Yes,
yeah.
what
All
is
right.
it equal? Same of?
The sum of the atomic weights of a compound. And that will be given to you. Hold on 1 second. Well, hold on more than 1 second, because we're going to go to Blackboard. And course information in the lecture folder. If you go all near the way to the bottom, hopefully you're all seeing that, you'll see important information, test number 2. Let's open it up. All right, I've been jumping around. Thumbs up, people. I gotta find some people with their. You see it, right? All right, you'll see test important information, and you should look at this. And if you notice right over here, the molecular weight of a compound equals the sum of all atomic weights of a compound. And I could have put down here in grams, which I probably will correct at a later date. And this is all going to be given to you. A couple of years ago, I used to make students memorize this, and as I told you, I've changed my philosophy on that. And same thing here. Here are the shells and subshells, which you don't have to memorize, and students used to. So, first of all, does that help whoever asked that question? I think it was Kelly. Great. All right. Remember, take a look when you have a chance in the lecture folder for important information, test number 2. And these are things I'm going through now that you don't have to memorize. Yes, there will be some things that you have to memorize, but this cuts down way a lot of what you have to memorize. All right. I better share. It's not polite to hog all the fun, so let's have you try one. How many grams of ammonia is 67.35 moles of ammonia? And something you can look up for yourself, but I'll give it to you. The atomic weights for nitrogen, 14.0, for hydrogen, the 3 significant figures, 1.01. And it's your turn. Oh, you're doing that? I'm going to take a walk around the block? No. I see smoke coming out of everybody's calculators from all the buttons being pushed. When you're done, look up. If you want, give me a thumbs up. I think everybody's just about done, but I'll give you a little more time. While you're doing that, let me just tell you about something. And that is, I seem to be finally getting into a pattern. And that is, I'll probably either the day before, or 2 days before your lab, post the lab scores for the lab you turned in last week. Yesterday and this morning, I was working on finishing up the lab you handed in last week. And don't forget, this week, there'll be a lab to hand in, so hand it in, because there are easy points that you shouldn't lose. All right, let's do this. What are we being asked to find? And the answer is how many grams of ammonia? Right here. What are we given? This number. We have 6.35 moles of ammonia. And now, how do we begin? Well, this is the only number we have. $67.35 moles of ammonia. And if there were some ratio, we can multiply it to get to the units of the answer we want. What are we trying to get? Grams of ammonia. And now, guess what time it is? Yes, it's time to use your good buddy, your good friend, unit analysis. I love that whistle. And whatever you're trying to get to, the units go on top of the ratio. Whatever we're trying to get rid of, they go on the bottom. And this would be grams of ammonia on top and moles of ammonia underneath. And where do we get those numbers? Well, if you're taking test number 2, you look at important information, and 1 mole of a compound equals the molecular weight of that compound in grams. You're not given that. And you have to calculate the molecular weight of a compound equals the sum of all atomic weights of that compound. So first of all, we have to do the molecular weight of ammonia. And here, ammonia, the molecular weight, and I use the MW as my abbreviation for molecular weight. You have 1 nitrogen, 3 hydrogen. Each nitrogen has an atomic weight to 3 significant figures, 14.0. Each hydrogen has an atomic weight of 1.01. Do the math, the multiplication. Add this up. Remember, you get the same number of significant figures to the right of the decimal as the number that has the fewest to the right of the decimal. This is 1, 2. So this should have 1. Drop to 3 because that's 4 less. And the molecular weight is 17.0. 1 mole of a compound equals its molecular weight. For this case, it's 17.0 for ammonia. And now before I pick up my calculator, I'll check do my units cancel out so I get this correctly. And moles of ammonia divided by moles of ammonia. Remember, anything divided by itself equals 1, which means it cancels out. These cancel out. I'm left with grams of ammonia, which means I'm on the right track. And it's time for me to pick up my calculator, which I'll do right now. And notice the first number is 4 significant, second one is 3. Hit enter. Whoa, that was quick. And I get that number, and I'll round it off to 3 significant figures, but I'll give you 4 seconds to try first. 1, 2, 3, 3.6, 3.8. Time's up. Keep the 3, keep the 9, keep the 6. Use the 1 to round off. That's 4 or less. So the answer would be 3.96. And someone probably beat me to it. I think I made a mistake. Hold on. Yep, Dr. White made a mistake once in a while when I'm switching back and forth. And if you had done the same thing and put the wrong numbers in, I divided, I should have multiplied. Let me go back and correct that. And if you put down this number but showed me your work, I said, oh, you made a math error. Instead of giving you 0 points, I'd take off 1. So let's try this one again. And this is the number you get. And if you round it off, you get 1,140. Or if we did it in scientific notation, which probably a lot of you've done, let's come over here. And you round this off and you get 1.14 times 10 to the third. Keep the 1, keep the 1, keep the 4, use the 4 to round off. It's 4 or less, drop it. And so the answer is 1.14 times 10 to the third. And you just saw an important demonstration of Dr. White doesn't walk on water unless it's frozen. In other words, I make mistakes, but I try and catch them. And either answer would be correct on a test because they're both the 3 significant figures. But for you, it's probably easier doing it in scientific notation. Oh, this is fun. Let's do another one.
Dr. White,
Yes.
on that last problem, so the 3 significant, you have to put in the 0, correct, after it?
Hold on. Can you repeat that again?
For your answer, you got 114. Is that a 0 after it, correct?
Yes. If you look at, and let's take a look. And you know how to do this, you being all the students, how would you write 1140 in scientific notation? Here's the decimal, move it to the right of the first non-zero number. You moved it 3 times, drop the 0 at the end, it will be 1.14 times 10 to the third. So the answer is yes, that's 1140, and that's a gram. Is that better? By the way, on a whiteboard in a classroom, students will ask me, what's that? All right. let's get back to your problem to try. And that's how many moles sodium hydroxide is 7.5 times 10 to the third grams of sodium hydroxide. And I'll help you out, but you should be able to figure this out. Sodium atomic weight is 23.0 to 3 significant figures. Oxygen is 16.0 and hydrogen is 1.01. And have fun. Is chemistry fun when you use your good buddy, your good friend, unit analysis? Everybody say, yes, it is. No, you don't have to. One of your colleagues asked a question about negative versus positive exponents. When we finish this, I'll do one with negative ones. All right, anybody need more time? Let's do it. All right, what are we being asked to find? How many moles NaOH, sodium hydroxide? What are we given? How many grams of sodium hydroxide do we have? Now, we only have one number to start with, so I'm going to start with that number. And if I had a magic ratio to convert this into my answer, by the way, that's a G. I'm having a bad G morning. Anyways, what are we trying to get to? Moles of NaOH. And it's time to use your good buddy, your good friend, unit analysis. I'm going to make you guess when I'll use the whistle. And whatever you're trying to get to goes on top of the ratio, unit-wise. Whatever you're trying to get rid of goes underneath at the bottom of the ratio. So I have moles of NaOH divided by grams of NaOH. Where do I get these numbers? Well, you look at the following. 1 mole of a compound equals the molecular weight of that compound in grams. And the molecular weight of a compound is the sum of all atomic weights in that compound in grams. And therefore, we go back, actually don't even need the in grams there. We need, for every 1 mole of sodium hydroxide, you have the molecular weight of sodium hydroxide. How do I get that? The molecular weight equals the sum of all atomic weights in the molecule. And therefore, 1 sodium, 1 oxygen, 1 hydrogen. This is 23.0. The 3 significant figures, this is 16.0. This is 1.01. Add them up. I get 40.01. This is 2 past the decimal, 1 past the decimal. All right, this is 1. I'm working ahead of myself. And this is 2, which is the smallest number, 1. Keep the 0, round that, drop the 1, because that's 4 or less. So what's the molecular weight of sodium hydroxide? 40.0. I look at this and say, check units, grams of sodium hydroxide divided by grams. I'm left with the right units. Now I can go to my calculator. And notice the number I get is this. And if you look, I had 7.5 divided by 40.0, 2 significant divided by 3. You should have 2 significant figures. Round this off to 2 significant figures. Keep the 1, keep the 8. I use 7, that's 5 or greater. Drop that and everything. That's 1.9 times 10 squared. And that's the number you get. Now, one of your colleagues asked a good question, and let's do the following. But first, I see a question. Do you want me to go through what I did? If you look here, I took 17.5 times 10 to the third and divided it by 40.0. Gabrielle, does that help you?
You said 17.5, ain't it 7.5?
Did I put in 17?
I'm not quite sure.
No,
I wasn't paying attention.
You weren't? Well, I'll forgive you. All right, let's do it again, see if I did it right. 7.5 times 10 to the third divided by 40.0. Same answer, so I got it right, but that's a good question. And now you know I did. Once in a while.
Thank you, Doctor.
You're welcome. Remember, all questions are good questions in my class.
Hey, Dr. White, quick question. Do you recommend just to use it in our calculator in science?
I would say for scientific notation, leave it in that. That'll work for me. I like switching back and forth. That's just because I grew up with a slide rule.
Right, I've been switching back and forth on, but some of the answers are kind of off when you do it the other way.
Well, do it whichever way is more comfortable. And I think for you people, it would be scientific notation. All right, let's do one. We're running out of time. And the question is, how many grams of water is 4.56 times 10 to the minus 2 moles of water? Dr. White will do this one so I can let you out on time. Don't forget, those of you like pets, stick around. Oops, see, rushing makes mistakes. What are we trying to find? Grams of water. What are we given? 4.56 times 10 to the minus 2 moles of water. Therefore, the only thing we have to start with is this. It's very important to put the units down. And if I have a ratio, what do I want to get to? I want to get to grams of water. Now I use my good buddy, my good friend, unit analysis. Whatever I'm trying to get to goes on top of this ratio. Whatever I'm trying to get rid of goes underneath. And here, this would be grams of water. This would be moles of water. Where do I get that? 1 mole of a compound equals its molecular weight in grams of the compound. And we've already done water. And water, 1 mole equals 18.0 grams. And now I'll take and look, do my units cancels out? Moles of water divided by moles of water. Anything divided by itself equals the number 1. Therefore, this cancels out. And now it's time to go to my calculator. I write the number down on a piece of paper so I don't. Bad habit of mine is transposing figures. So I'm going to go to my calculator now. I'll do it in scientific notation. 4.56 E. Remember, use the white minus key on your calculator, not the one used for subtraction, times 18.0. And oh no, Dr. White forgot to do the plus sign, which I do on a spreadsheet every once in a while. And this is a number I get. And if you look at the two numbers, they were both 3 significant figures. So round that off to 3 significant figures. Times up, keep the 8, keep the 2, keep the 0. Use the 8 to round off. And that's 5 or higher. Increase the 0 by 1. So you get 8.21 times 10 to the minus 1. Let me rewrite that. And that's your answer. And that's how you use moles and grams. And 1 mole of an element equals its atomic weight, and 1 mole of a compound equals the molecular weight. And if I look at the clock, I'm just about out of time. Don't forget, keep up with the problem sets. We'll do chapter 10 on Thursday and Friday. Don't forget, if you haven't handed in the lab last week, do it now. Otherwise, you'll lose 10 points, which will hurt your grade. It always will. And so hand in your labs. And with that, I'm done. Those of you who want, stick around for a nice pet story. For those of you who don't, goodbye. Gang gesund.